Welcome. In this session, we are going to illustrate how to solve simultaneous equations by method of substitution. So we'll illustrate using examples. So steps. So step 1, select one of the equation and solve for one of the unknowns in terms of the other. So select one of the equations and solve for one of the unknowns in terms of the other. Number 2, substitute and this explains why the method is called substitution. Substitute this expression into the equation not used in step 1. And then final number 3, solve this resulting equation in one variable and use the solution to get the other unknown. So now let's demonstrate how this works on a specific example. So examples. Solve by substitution method. So the first set of equations is 2x plus 2y equals -1 and 4x minus 3y equals to 18. Now, when we check these two equations, we see that in the first equation, it is very easy to express x in terms of y. So we say, if I label this one equation 1, label this one equation 2. So from equation 1, we have x equals to -1 minus 2y. Then I can call this one equation 3. Now substitute equation 3 into equation 2 because we didn't use 2 to get this one. So remember, step 2 was to replace the expression you have into the equation that wasn't used to get the new expression, i.e., where is x will be replaced by -1 minus 2y. So we'll have this one will be 4 into -1 minus 2y minus 3y equals to 18. So 4 by -1 is -4 minus 8y minus 3y equals to 18. Minus 8y minus 3y is minus 11y, which is equals to 18. And then collect like terms, minus 11y equals to 18 plus 4. And 18 plus 4 is 22, so minus 11y equals to 22. which implies to get y, we divide through by minus 11, which means y equals to minus 2. Now, once you get the value of y equals to minus 2, you can always get x from equation 3, which means x will be minus 1 minus 2, but the place of y you put minus 2, which will be minus 1 plus 4. This gives you 3. Hence, the solution x equals to 3 and y equals to minus 2 is the solution of the simultaneous equations. That's example 1. Example 2, 5x minus 2y equals to 4 and 2x plus 3y equals to 10. So let's pick any of the equation and make one variable the subject of the formula. If I call the equation 1, this one equation 2, then remember you are free to pick any of the equation. So from equation 2, if we want to make x the subject, so we'll have 2x equals to 10 minus 3y, which means x will be 10 minus 3y divided by 2. And I call this one equation 3. Now substitute equation 3 into equation 1. That means that where there's x in equation 1, we put this expression. So we'll have 5 into 10 minus 3y over 2 minus 2y equals to 4. Then this is the same as 5 by 10 is 50. 5 by minus 3 is minus 15y divided by 2 minus 2y equals to 4. Now, the easiest way is to multiply each term by 2. So which means 2 by 50 minus 15y over 2 minus 2 times 2y equals to 4 times 2. So I'll multiply 2 by every term in the equation. So this and this cancels out. So we'll have 50 minus 15y minus 4y equals to 8. So 50 minus 19y equals to 8. And then this will be 50 minus 8 equals to 19y. So 42 equals to 19y. So which means y will be 42 over 19. So this is the solution for y. Now to get x, I will have x will be 10 minus 3 times 42 over 19 divided by 2. This was from equation 3. So which will give us 10 minus, so 42 by 3. So 42 by 3, so we'll have 6, 12 over 19. So 1.6 over 19 divided by 2. So 10 minus 126 over 19. This LCM is 19. So we have 190 minus 126. So 190 minus 126, this is 4. 8 minus 2 is 6. So we'll have 64 over 19 divided by 2. This is what is giving us x. Now 64 over 19 times a half is the reciprocal of this, so which will give us 32 over 19. So x will be 32 divided by 19. So therefore, those are the two values or solutions for that given simultaneous equation. Next example, number 3, we have 7x minus 2y equals to 26 and 6x plus 5y equals to 29. So in this case, if we call this one equation 1, this one equation 2, so from 1, we can actually make y the subject, so 2y equals to 7x minus 26. I've simply taken this to the right and this one to the left. So which means y is 7x minus 26 divided by 2. I call this one equation 3. Now substitute equation 3 in equation 2. That's, I mean, I have 6x plus, where this y I put 7x minus 26 over 2 equals to 29. So this will be 6x plus 5 times 7 is 35. X minus 5 by 26, so 26, 5, 30, 10, 13, 130 divided by 2 equals to 29. So which means multiplying everything by 2, I'll have 12x plus 35, x minus 130 equals to 58. Now 12 plus 35, this is 47. So 47 x equals to 58 plus 130. So 58 plus 130, this is 8, 8, 1. So 47x equals to 188. Now, which means x will be 188 over 47, and this gives us 4. To get y, we use equation 3. So y equals to, equation 3 is 7x, so 7 times 4 minus 26 over 2, which will be 28 minus 26 over 2, and y will be 2 over 2, which is 1. So the value for x is 4, and the value of y is 1. Lastly, we have x plus y equals to 2, and 2x plus 2y equals to 2. Now from equation 1, x equals to 2 minus y. Let's make call this one 1, this one 2, and this one 3. So substitute 3 into 1 into 2. So that I will have 2 into 2 minus y plus 2y equals to 2. So 4 minus 2y plus 2y equals to 2. So this gives us 4 equals to 2 because minus 2y and 2y is 0. This is absurd. Absurd or contradiction because 4 cannot be the same as 2. So the statement 4 equals to 2 is a contradiction. False statement. Thus, no values of x and y satisfy the system. Hence, no solution. So that's how we solve that given problem. And then lastly, maybe let's see, if we have x minus y equals to minus 2 2x plus 2y equals to 4. Now, this is equation 1, this equation 2. So from equation 1, we have x equals to y minus 2. Let's call this one equation 3. Now, substituting 3 in 2, we get minus 2 into y minus 2 plus 2y equals to 4. Opening brackets, minus 2y plus 4 plus 2y equals to 4. Minus 2y plus 2y is 0, so 4 equals to 4. And actually, it's a true statement. Four equals to 4 is a true statement, but the only problem is that now we have already eliminated the variables in the equation. So in this case, this means all solutions of one equation will also satisfy the other equation. So hence, this system has infinitely many solutions. And so x minus y equals to minus 2 means x equals to y minus 2. So we let y to be t, where t is any real number. So the parametric solution is y equals to t and x equals to, now where the y put t minus 2, where t is a real number. So please note that x minus y equals to minus 2 and minus 2x plus 2y equals to 4 represents the same line. What they have just done is to multiply this equation by -2 to get this other equation. So it is the same thing. So this is the parametric solution for the system, and it's actually the same line. So that's how we solve simultaneous equations by substitution method. You simply express one unknown in one equation in terms of the other, then substitute the resulting expression into the other equation and solve for one unknown. Once you get the answer, replace into the other equation to get the second unknown. Thank you.